Hi friends, so let's continue our question and answers about reflection and refraction. So the question is given a few uses of concave mirror and convex mirror. See, concave mirror is used in vehicle headlight lamps and torches, etc. Okay, this is because the lamp is placed at the focus and the emanated rays will be reflected parallel to the principal axis. Okay. The uses of convex mirror is it's used in rear view mirrors. Okay, this is because we want to observe many vehicles around us and ensure that we are driving safely. That's why we use the convex mirror as a rear view mirror. Okay, next question. Radius of curvature R of a mirror is 20 centimeter. Focal length equal to what? Okay, we know the formula. R is equal to 2 times the focal length, right? So what we do, we substitute for R, which is given as 20 centimeter, is equal to 2 times f, which implies f is equal to 20 by 2, that is 10 centimeter. So the focal length is 10 centimeter. Next question. Which mirror gives enlarged and erect image? Okay, answer is the concave mirror gives enlarged and erect image when the object is placed between the focus f and the pole, which is usually denoted by O. Next question. Why do we prefer convex mirror in rear view mirrors? Convex mirror gives diminished view of many vehicles but a broad coverage of vehicles behind us, so it is used in the rear view mirror. Okay. Next question. Describe 2D coordinate system. Okay. So whenever you want to use the formula for calculating the position and size of images, etc., you need to understand the 2D coordinate system. So what is the 2D coordinate system? You have learned about this already in your previous classes. There is a coordinate system X which goes from left to right. Okay, O is the origin where it is 0, and as we proceed towards our right, X goes on increasing. See, from 0 to 1 to 2 to 3 and so on and so forth, it keeps on increasing. Okay, and if you go towards the left, it keeps on decreasing. From 0 it goes to -1, -1, if you take one step to the left, -2, then -3, and so on and so forth. Okay, so there is another axis which is perpendicular to x-axis, which is the y-axis. Okay, so y-axis is positive as you go up. So when you go from 0 along y-axis, you'll get a 1, then you'll get a 2, and so on and so forth. And when you go down, it is negative, right? So when you go down, you'll get -1 along y, -2 along y, and so on and so forth. So this is the 2D coordinate system. Okay, this coordinate system is helpful in locating any position of any point in the 2D space. 2D space is what? It is a plane, right? So in 2D space, suppose I want to locate point A, I must first move 3 units along the x-axis and positive 1 unit along the y-axis. So I can denote it by 3, 1, right? Similarly, if I want to locate point B, I want to move 2 units along the x-axis and -1 unit along the y-axis. So it can be denoted as 2, -1. Similarly, if I want to locate C, I have to go first -1 unit along the x-axis and then -1 unit along the y-axis to give C equal to 1, -1, 1. Okay, so this is our 2D coordinate system. Okay, so O is the origin, X increases to the right, decreases to the left, which is negative. Okay, Y increases to the north. Okay, so if you go north, Y is increasing, right? And when you go south, Y starts decreasing. Okay, so this is the 2D coordinate system. Now this coordinate system will help you in calculating the object distances, image distances with respect to focal length. Okay, that's why it's important to understand this 2D coordinate system. Okay, so if a concave mirror is placed in a coordinate system, that is 2D coordinate system, with pole at the origin, okay, draw the diagram and describe the setup. Okay, so here what you see is the same 2D coordinate system where X is increasing positively, negatively on the left, plus Y and -Y, and we have a concave mirror which is placed such that the pole of the mirror is at the origin. Okay, so if you take a scale and measure you will get OC is minus 2.5 centimeter. So OC is minus 2.5 centimeter, which means that the radius of curvature is minus 2.5 centimeter. Okay, OF, okay, is the focal length, right, which is radius of curvature by 2, which is OC by 2, which is 2.5 by 2, that is minus 1.25 centimeter, because it's along the negative. Okay, so here is the origin. So everything, all the distances which you will be calculating on this side of the x-axis are negative. Okay, so the radius of curvature OC is minus 2.5, the focal length OF is minus 1.25. Okay, so hope that is understood, because it's along the negative x-axis. AB, okay, AB, if you take a scale and measure, it is 0.8 centimeter, and plus sign is given to it because it's along the positive y-axis. Okay, so this is from origin, when you go up, it is positive y. So we're getting 0.8 centimeter, which is positive y-axis. A dash, B dash, if you take a scale, okay, this ray diagram you have already seen before, right? A ray parallel to the principal axis get reflected through the focal point, and another ray which is passing through C, coming along the radius of the curvature, gets reflected along the same line but in the opposite direction, and these two rays intersect, and where it intersects, the image is formed. This ray diagram you have already seen, right? If you draw this ray diagram and take a scale and measure how much is A dash, B dash, A dash, B dash turns out to be 0.4 centimeter, but a negative sign is given because you can see you are measuring along the, from origin you are going down, so that is negative y, so you are getting minus 0.4 centimeter. Okay, so OB, object distance. So OB is the object distance. What is object distance? Object distance is the distance along the principal axis where the object is placed. Okay, OB, if you take the scale and measure, you will get 2.9 centimeter from here to here, but it is given a negative sign because it's along the negative x-axis. Okay, and OB dash, okay, OB dash is the image distance. Why? Because that is where the image is formed. So OB dash, if you take a scale and measure, you will get 1.7 centimeter. That is also given a negative sign because it's along the negative x-axis. Okay, so remember friends, this coordinate system such that the pole of the mirror at the origin has to be drawn perfectly, and you have to put the positive and negative signs correctly to get the correct answers. Okay, anything to the left of the origin, if you are considering, it is negative. Anything you are considering towards the right side of the origin is positive for x, and for the height, anything north is positive, anything which is south is negative. Okay, next question, describe the mirror formula. Okay, mirror formula allows us to calculate the image distance given the object distance and the focal length. So there is a relationship between the object distance. So in this case, as you can see, OB is the object distance, OB dash is the image distance, right? So, and OF is the focal length. So there is a relationship between the image distance, object distance, and the focal length. Mirror formula gives that relationship. If you call V as the image distance and U as the object distance and F as the focal length, 1 upon V plus 1 upon U is equal to 1 upon F. Okay, this mirror formula holds good for all the cases for both concave as well as convex mirrors. 1 upon U, 1 upon V plus 1 upon U is equal to 1 upon F. Please remember this formula. This is the mirror formula. So let's work out some problems. Before that, let's look at the magnification formula. Magnification means, what is the magnification formula? Magnification formula for mirror allows us to calculate the image size given the object size. Okay, so let's say h dash is the height of the image and h is the height of the object. The formula says h dash by h is equal to minus v by u. Okay, remember this formula. well. We are saying h dash, which is the image size divided by the object size, is equal to minus of image distance divided by the object distance. Okay, so that is what the magnification formula says. So let's work out some of the problems using these formulas. So we have one problem here. Convex mirror used as a rear view mirror has a radius of curvature 3 meters. Okay, it is given that radius of curvature, that is r, is 3 meter. Okay, if the bus is located at 5 meter in front of the mirror. Okay, so bus is an object, it is located 5 meter in front of the mirror. So we are given u also, which is the object distance. Find the position, nature and the size of image. Okay, so to solve this problem, first you should put the coordinate system. Here I have put it here. So you can see that this is minus x to x, this is minus y to y. This coordinate system roughly I have drawn, and it is a convex mirror used in the rear view mirror. So when you draw a convex mirror with origin at its pole, you can see that this side is not the reflecting side, this side is the reflecting side. Okay, and they have also given that the bus is on this side, because see, this is the reflecting side, this is the rear view mirror. That means bus is in front of the mirror, correct? So it is on the negative side. Okay, so given that r is 3 meter, which is given, right? Radius of curvature is 3 meters. Okay, now we have taken it as positive because for a convex lens, the center of curvature is along the positive x-axis. Do you see that? This is the convex lens. The center of curvature is here. The focal length is half distance of center of curvature. So the center of curvature for a convex mirror is along the positive x-axis. So we are taking this as positive. So radius of curvature is 3, right? So focal length is 3 by 2, that is 1.5 meter. Okay, 1.5 again is positive because it's along the positive x-axis. Okay, and OB, that is the object distance. See, if the bus is at B, OB, which is the object distance, is 5 meter. But we are taking it as negative. Why? Because see, this is along the negative x-axis. This is to the left of the origin. Okay, so you must be careful here and take minus 5 meter. They are asking what is, find the position of image, position, nature and size of image. Okay, so they are asking what is V and what is H dash. Okay, so we use our formula, which is the mirror formula, 1 by V plus 1 by U is equal to 1 by F, which implies if I take 1 by U to the other side, I'll get 1 by V is equal to 1 by F minus 1 by U. Okay, now F we know is 1.5 and it is positive because it's along the positive x-axis, so we substitute 1.5 here. Okay, and U we know is 5 minus 5 because it's along the negative x-axis, we substitute minus 5 here. Okay, so this minus and this minus gets cancelled, we get 1.1 divided by 1.5 plus 1 by 5. So to take the LCM, since this is a decimal and this is not a decimal, we just multiply these two guys. So the LCM is 1.5 into 5. Okay, so to make this denominator as LCM, we multiply both the denominator and the numerator by 5. Okay, so 1.5 times 5 and 1 times 5, so we get a 5 here. To make this denominator the LCM, we have to multiply by 1.5, both the numerator and denominator, so we get 1.5 here. And then after taking the LCM, we can add these both. 5 plus 1.5, 6.5, and denominator 1.5 into 5 is 7.5. All these calculations you can do using a calculator. Okay, you can use the calculator and do the multiplication, addition, everything. Okay, so if 1 by V is 6.5 by 7.5, V is inverse of that, right? So it's 7.5 by 6.5. Again, by using calculator, you can do, you'll get the answer as 1.15. Okay, now 1.15, we have got it as positive, which means the image is on this side. Image is on the positive side of the x-axis, which means image is behind the mirror. Okay, which means image is virtual. Okay, see, you have got V is equal to 1.15, which is along the positive x-axis, and the mirror is here, and anything along the positive of x-axis is behind the mirror, right? So image is at 1.15 meter from the pole along the positive x-axis, so it's a virtual image. Okay, and what is the ratio of height of the image to height of the object? Okay, we use our magnification formula, h dash by h is equal to minus u by v, minus v by u, sorry, h dash by h is equal to minus v by u. So v is our image distance, which we have calculated it as 1.15, and u, we already know that we are substituting it as minus 5. Okay, so u is minus 5, but there is already a minus sign in the formula, so that minus and this minus gets cancelled. 1.15 divided by 5, you get, again using the calculator, you can see that it is 0.23. Okay, so the image is 1.15 meter along the positive x-axis, and it is virtual because it's behind the mirror, and image size to object size ratio is 0.23. Okay, now let's do one more problem. Object of size 4 centimeter, okay, is placed 25 centimeter in front of a concave mirror. So they have given the size of the object as well as the object distance, okay, of focal length 15 centimeter. They have also given you the focal length. At what distance should the screen be placed to obtain a sharp image? So if you want to position the screen, you should know where the image is formed, okay, what is the image distance. If you place the screen at that image distance, you will get the sharp image. So we have to find the image distance and what is the nature and size of the image. Okay, so again you have to start with the coordinate system. So you have to draw the coordinate system, plus y to minus y and plus x to minus x, and this time it is a concave mirror. Okay, so the mirror is like this, and the back side of the mirror is solid, and the front side of the mirror is reflective. Okay, so here's the center of curvature, here's the focal length, and the focal length and the radius, everything is negative. Why? Because it's along the negative x-axis. Okay, so let us write down what is given first. Given that h object size is 4 centimeter, we have written it down, and it's placed at 25 centimeter in front of the concave mirror. So if you want to place something in front of the concave mirror, you have to place it somewhere here, isn't it? Because see, mirror is reflective on this side. So if you want to place it in front, you have to place it here. So object distance is 25, but we have taken the minus sign. Minus sign is because OB, that is the object distance, is negative, is along the negative x-axis. So this is important. The u, which is the object distance, they have given it as 25, but we must take it as minus 25 because we are placing it along the negative x-axis, because this is a concave mirror. Okay, and what about the focal length? Focal length also they have given 15 centimeter, but we have to take it as minus 15. The sign should be minus 15, negative, because it's along the negative x-axis. 0f is length 15, but 0f is along the negative of x-axis, therefore it is minus 15. Okay, so we have our mirror formula, 1 by v plus 1 by u is equal to 1 by f. 1 by v is equal to 1 by f minus 1 by u, and we can substitute. So what is f? F is minus 15, we have substituted. Okay, what is u? U is equal to minus 25, that we have substituted. This minus and plus becomes minus, and this minus and minus becomes plus. So we get minus 1 by 15 plus 1 by 25. Now this denominators are not the same, so we have to take an LCM. So here you can see we are taking the LCM. So 15 and 25, I hope you remember how to take LCM. 15 and 25 we write, 5 divides both of them, so 5 3s are, 5 5s are, then 3 1s are, 5 remains as is, then 5 1 and 1. Okay, so LCM is 5 multiplied by 3 multiplied by 5, which is nothing but 75. Okay, so if you want to make this 75, you have to multiply numerator and denominator by 5. So we have done that. So in numerator you will get 5, but minus sign is there, minus 5. To make 25 75, you have to multiply by 3. So we have done that. So numerator you have got 3. So 1 by v is equal to minus 2 by 75, or v is equal to minus 75 by 2. It just gets inverted because 1 by v is this, means v is this. So V is minus 37.5. So the image distance, you are getting it as negative. What does it mean? It means image will be formed somewhere along the negative of the x-axis. So you have to place your screen. The screen must be placed 37.5 centimeter along the negative x-axis, okay, to get a sharp image. And to calculate the height of the image, we have been given the object size is 4 centimeter, and we know the magnification formula h dash by h is equal to minus v by u, okay, which implies h dash by h is 4. We are substituting 4 here, and minus, okay, what is v? V is minus 37.5. What is u? U is minus 25. We have got it. This minus and this minus cancel, but there is one more minus remaining here. So if you use a calculator and divide 37.5 by 25, you will get 1.5. And this minus sign remains as this. Only these two signs get cancelled. Okay. So h dash is equal to, this denominator goes to the numerator, right? So you'll get 4 into minus 1.5, that is minus 6 centimeter, which means the image is formed such that its height is minus 6 centimeter, which means it is an inverted image because it's going along the negative y-axis. So it's a real image because it's getting formed in front of the mirror, okay, and it is an enlarged image because object size is 4 whereas image size is 6, minus 6 because it's an inverted image. Thanks, folks.